So, Jai Hind. So, in continuation of the previous lecture, where we have discussed some IPv4 header format, what are the information that is contained by the IPv header. IPv4 header basically that is very important at that work at the network layer, because at the network layer each and every packet is attached with a additional header that is known as IPv4. If we are means taking the IPv4 version protocol, then IPv4 header, and if we are using the IPv6 header means addressing, then we can use the IPv4 IPv6 header. So, let us see some numerical example when we have given the data stream, how we can decide the what is the TTL, what is the source ID, source IP and destination IP, what is the size of data, what is the size of header length, all these information we will see in this lecture. So, that will be very interesting and beneficial lecture to understand the example, because in university examination many times they have given this binary stream and they have asked what should be the TTL information, how many router can be traveled by this packet, okay, and what is the source IP, what is the destination IP, what is the header length. So, all these number of information can be asked on the basis of IPv4 header. So, this is the same IPv4, this is the 5 layer, 5 rows, and each rows is divided into some field that is that contain the some basic information. Okay. So, let me see a particular example. This is the type of service basically. Okay. Type of service by how many bits? Here recognize 8 bit is used to identify the which type of service is there, which type of service is provided in this particular transmission. So, these are the type of services. If there is a 0000, so here in this, this is the 8 bit 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, here the first 3 bit is reserved, does not use, and the last one is also not in use. These are the 4 field that may contain the some information data field. Like if these are the 000, this is normal default data. If this contains 0001, this is the minimized cost. That means this data should be delivered with minimum cost. If 01000, this is the maximum reliability. Reliability should be there. Maximum reliability should be ensured. If that is the 1000, this is the minimized delay. There should be least delay, means fast delivery should be required. So, these are the type of services. Let us take the example that is very important. Suppose an IPv4 datagram has arrived with the following information in the header. This is given in the hexadecimal. Okay. So, as we know that each and every hexadecimal have 4 bit equal to 4 bit. Each symbol is represented in binary 4 bit. If we talk about the hexadecimal symbol, so this is 4. That means this is the in binary. This is the 4 bit, which value is 4. Okay, like that. So, this is all these symbol are in hexadecimal. Okay, these are some questions. What is the header size? What is the header length? Are there any options? Is the packet fragmented? What is the size of data? How many more router can be packet travel? This router information is deal by TTL information, time to live. What is the identification number of packet? What is the type of service? What is the destination IP address? Is the packet is corrupted and why? These are the number of questions that you have to answer on the basis of this hexadecimal pattern. So, we will take this example, this one, and we divide this in the form of header format. So, to solve this question, you should have a very clear idea and the information about the header format of IPv4. Okay. So, there should be this 5 basic layer 1, 2, 3, 4, 5, and this 6th may be optional, that may contain or may not contain 0 to 40 bits basically. 40 bytes, 0 to 40 bytes. So, this is the first version, then header length, then this. So all information is breaked from this binary, this hexadecimal pattern to here. So as we know that this is a 4-bit, each one. So first 4-bit is reserved for the version. So 4-bit means this is the first symbol, because each symbol of 4-bit. So this 4 is written here in version. Let us first write each and every values for each and every particular field. So we adjust these given values in the particular field. Then we will try to give the answer. Then this is the HLN. We know that HLN is also of 4-bit, okay, and each and every symbol of 4-bit. So next 4-bit, that means this 5 value is given here, okay, 5. This is the single symbol here in hexadecimal, but in binary this is the 4-bit. Each symbol of 4-bit, you know that in hexadecimal. This DS, okay. So DS is of 8-bit. This is what is DS? Let us type of service. Tell me service type. Service type. Type of service of 8-bit. 8-bit means by using two symbol of hexadecimal. So next 2 symbol is 0 0. So 0 0 is written here. Next 16-bit. 16-bit of total length, for total length. So 16-bit means 4 symbol, na? The next 4 symbol, this one, 0054 is written here. Then identification of 16-bit. 16-bit means 4 symbol, next 4 symbol. So 002, this one, 0003, this is written here. Next flag of 3-bit. Flag and this particular offset of 13 this and 3, 16-bit. So next 16 means 4 symbol is written here, 00 and this is 00, offset 00. Then TTL, time to live. How many byte? Let's see here. 8-bit. 8-bit means 2 symbol are required here. So next 2 symbol, that is 20, is written here, TTL. Okay. Then protocol of 8-bit. Type of protocol. So this next 206 is written here. This is of protocol. Next 16-bit. 16-bit means 4 symbol. That is the 0000 is written here. Checksum. Okay. So we come till this one. Next source IP of 16, 32-bit. 32 means 8 symbol. 8 4 are 32. 8 symbol. 1, 2, 3, 4, 5, 6, 7, 8. This one the source IP. Next 8 symbol is destination IP. Last one. So this is written here, Okay. So here very clear, source IP is this one. So this source IP in hexadecimal, when it converted into decimal, so this give this 124. Okay. 124 in dotted decimal notation, we know that we represent in octant separated by decimal. Octant means 8-bit. 8-bit means 2 symbol. Okay, na? So 2 symbol this one, next 2 symbol this, next 2 symbol this, next 2 symbol this. Okay. So first this 2 symbol 7C. 7C is converted into decimal. That give the 124. So you have idea how to convert. This is base 0, this is 1. So 16 into 16 power 0. C means 13 into 16 power 0 plus 7 into 16 power 1 plus this one, na? So that give the 124. 124. Similarly here E and 0, this give 78 in decimal notation. Similarly this 03, this give 3 in decimal. So here written 3 and 02. 02 is written as 2 in decimal. Okay. So that is given here. So this is basically in dotted decimal notation 124.78.3.2. This is the source IP. Similarly, 180.14.115.2 is the destination IP. Okay, this is coming from last two layer. This one. Other information, let me check. Yes. Is the packet corrupted? Why? Okay. So here we achieve that header length. Okay. What is the header information? It is 4. If we come here, header information is 4. This is header information is 5. So we multiply with the scaling factor 4. 5 into 4, that is the 20. So this gives the 20 byte. Okay. This gives the 20 byte. So header length should be minimum 20 byte. Hence it is not corrupted. As we know that if this is corrupted, that may be changed. So minimum at least there should be 20 byte. And we see that in this packet we achieve the 20 byte of the header size. Okay, so that means the packet is not corrupted. Next, size of option field, size of HLN equal minus 20, that is the 0. Option means, last one size, na? 6th row. If we come at this one, this is the option. Is there is a value in option? So whenever you have some value in one option from 0 to 40 byte, certainly your header size will be more than 20. Okay, because 20 should be at least without option, and we achieve 20. Suppose if we get 25, that means 20 is the minimum required field compulsory, and this 5 may be of this 5 certainly will be of option. But here in this case we get 20 byte only for the header length. That's why we have 0 value in the option, no value in the option. This is the second question. What is the size of data? Very important. So size of data, how you can decide the size of data? The size of data, total length minus header length. Okay, total length minus header length. So total length is the header length plus payload, that is the total length. Header plus payload, this is the total length. Header plus payload. Payload means data. And if you are asked the size of data, that means total length minus what one? Header length. Okay, that give the payload size or data size. So here we know that we have given in header in data size we have given 54 values. This is the hexadecimal value. So we have to convert into decimal first. So in decimal, equivalent of 54 hexadecimal, that give 84. You can convert easily. You have this one like this one, this 54 na. So 54 can be converted like 54. The indexing is 0 and 1. Now you can convert 5 into 16 power 1 plus 4 into 16 power 0. Okay, so that give 80 plus how much? 4. That give the 84. So basically here in this calculation this is shown. 84 will be the data size. Okay, whole total data size. So 84 minus 84 is the total header size, total data size, minus header length. Header length is of 20 byte. Okay, so how much? 64 byte is the actual size of payload. 64 is the actual size of payload. So what is the size of data? 64 byte. Okay. How many routers the packet travel to? This information is resolved as given as solved by the TTL field. TTL means time to live. So if the value of TTL is 4, what does it mean? It means that your packet can travel or can pass through at most 4 router. After 4 router, that will be dropped, that will be useless. So there is a TTL field, like TTL4 is 4. So whenever that pass first router, that value will be 3, 4 minus 1. Then that will pass the second router, this will be value will be 3 minus 1, 2. Now that means from this point that can traverse up to 2 more router. When that traverse to the third router, the value will be 2 minus 1, 1. What it mean? That means this packet from this point can traverse at most 1 more router. So when the fourth router will be crossed, the value will be 0, TTL. TTL 0 means now that is worthless. If that is delivered within that limit to the destination, that's okay, otherwise that will be dropped. So this is the TTL information. So here the TTL value is 20 is given, 20 in hexadecimal, okay. So when we convert into decimal, that will be 32, basically 32. So the answer will be how many router the packet travel to? The packet travel 32 routers, okay. TTL value 20. So 20 means in decimal 32, so 32 router can be traveled by the packet. What is the source IP? I have already told you the source IP. Source IP is there, this one, 124.78.3.2. Similarly, what is the destination IP? 180.14.15.2. This is this one. Fifth layer or fifth row will give the destination IP. How much symbol is there? 8 symbol, each of 4 bit, because this is a hexadecimal symbol, na? So 4 into 8, 32 bit long. Similarly, this is also 32 bit long. Packet is fragmented or not? Okay, packet is fragmented or not? So fragmentation plus fragmentation offset 5850. In binary, this one, the first 3 bit are flagged. So 0 1 0. This is converted into binary representation. So 0 1 0. Here second bit is 1. So second bit represent the don't fragment, means not allowed for the fragment. Okay, 0 1 0. This is the 3 flag. So second bit always represent the don't flag, don't fragment. Don't fragment. Okay, so don't fragment means this fragmentation is not allowed. There is a question now. This question, is the packet fragmented? No, packet is not fragmented because fragmentation is not allowed in this particular data header, header format. Okay, so similar to here, by using these calculation we can easily solve this particular question on the basis of this IPV4 datagram. Okay, so these streams are given and you are asked the number of questions here. Okay. So IPV4 header, this is the header information that guide the packet, how they are treated by the different intermediate node during the communication, during the transmission. And this IPV4 header formation, header information is very important, and this also provide the logical addressing, because this IPV4 source IP address and destination IP address is known as the logical addressing, because each and every node that is connected to a particular network has its own IP address, 32-bit IP address if you are talking about the IPV4, and 128-bit IP address if we are talking, we are using the IPv6 header. Okay. So IPv4 address basically the 32-bit address, okay, that uniquely and universally define the connection of a device. For example, a computer may be there, or a router may be there, or a bridge may be there to the internet. Okay. So IPv4 address are unique and universal, accepted, globally accepted. The address space 2 power 32, that means this one value. This is the address space. These much unique addresses may be assigned, may be generated by using this protocol. Okay. Three different notations are there in IPv4. Binary may be, okay, that means all the 32 bits represented into binary digit, binary bit. And this second one, most widely accepted and used, that is the dotted decimal notation. Dotted decimal notation, that means first octant is represented into decimal, second octant is represented into decimal, third octant in decimal, fourth octant in decimal, and all these octant are separated by the dot notation. That's why this is known as dotted decimal notation. And the last one is the hexadecimal. This is also most frequently used, okay, because less number of bits are required to represent this one. Okay, so that's why this is that means these 2 bit, that means this first octant is represented by the 2 symbol, second octant by 2 symbol in hexadecimal, third 2 symbol in hexadecimal, this 2 symbol in hexadecimal. Okay, so this is the 3 different kind of notation. So hierarchy of addressing. So in this particular IPv4 addressing, the whole 32 bit is divided into 2 most important field. First field deal with the network ID, that decide the which network, from which network this data belong, where this is supposed to deliver. And when this network ID decide at which network deliver, then in that particular network, what is the host ID where that have to deliver. Okay, so there is the net ID, first field, and second field is the host ID. So this IPv4 addressing space, address format is divided into 2 parts. First n bit, suppose, that is prefix for the network, and the last 32 minus n bit, that is suffix that decide the node or host ID at which device that packet supposed to be delivered. Okay, these 2 one. Change the following IPv4 address from binary notation to dotted decimal notation. So this is the simple question that arise into different competitive exam as well as university examinations. Like first one is given like this one, okay, in binary notation, you have to convert into dotted decimal notation. This is very important. So this binary value is first converted into decimal. Converted into decimal. Second one is also converted into decimal. Third one into decimal. Similarly, this last one is also converted into decimal. And there is a between these 2 decimal, there is a dot notation. Dot, dot. So this is the dotted decimal notation. First dot, second dot, third dot. Okay. So what should be, let me give the answer. What will be the value of this number in decimal? Anybody? So 1, how much 0? 1, 2, 3, 4, 5, 6, 0. 1, 2, 3, 4, 5, 6, 0, and then 1. So by assign the weight, you can easily identify. So this is the value of 1, 2, 4, 8, 16, 32, 64, 128. So which weight is present here? 1, that means 128, and other is 1, that means 1. So this is the value of 128 plus 1, 129. Okay, so this is the 129 in decimal. Similarly, you can check this one also. So 1, 2, 4, 8. So I think this is 11. This is 11. Similarly, this is also 11 dot 11, and this one check what value will be there. So how much one? This is the, let us see here. Just write this value here and try to convert into decimal. 1 1 1 triple 1. Okay, then 0, then 1 1 1 4 1. Let us assign the weight. Okay, in decimal 1 2 4 8 8 to 16 32 64 128 128. So 128 plus 128 plus 64, this is also present. 1 means present. 36 weight is also present. 32, sorry, 32, not 38. 36 not is there, 32 basically. So 64 and 32 present, and this 8 is present, 4 is present, 2 is present, and 1 is present. Okay, so write down the sum. So sum will be 239 here. Okay, you can easily find out sum. This is the 239. So value will be 239. So what is the dotted decimal notation of first IP address that is given in the binary? 129.11.11.239. Here is the answer. Okay. So similarly you can solve for the second also. Do it by yourself. Okay. So now thank you, and we will meet with some other most interesting and more important topic like TCP, and try to solve the numerical on the TCP header. Then for the UDP, and try to solve for the UDP header some numericals with the next lecture. Thank you. Thank you.